Hello students, welcome back to this lecture series of M.Sc. Part 1 Mathematical Methods in Physics. So in this class we are going to discuss solution of boundary value problem by using the Fourier integral transform. So first example, that is solve the equation du by dt is equal to dou square u by dou x square subject to the condition. First condition is given u at x is equal to 0. Okay, so we can write x and t is equal to 0 where x is equal to 0. Okay, this is for and second conditions, that is u at t is equal to 0, then it is or x and t. Okay. 1 and 0, 1 for the limit 0 where x is t is greater than 1 and here x is greater than 0. Okay, so these are the two conditions for this differential equations, and here we are going to apply the Fourier sign transformations, okay, to these differential equations. Okay, because here u is given at x is equal to 0. If du by dx is given at x is equal to 0, then we apply for the cosines transformations to solve these differential equations. Okay, so here I am going to use this sign transformations to solve these differential equations. Okay. So given, that is dou u by dou t is equal to dou square u by dou x square. So if I apply the Fourier sign transform, then it is 0 to integration over 0 to infinity dou u by dou t sin sx dx is equal to integrations from 0 to infinity dou square u by dou x square sin sx dx. Okay. This is after applying the Fourier sign transformation. So you can write this left hand side dou u bar by dou t is equal to, and here we can write s u where u s into u, this u is at x is equal to 0 minus s square u bar. Okay, so this is a formula for the dou square u by the dou x square for the sign transformations, and u bar is a transformation of this u. Okay, or also we can write u bar is a function of s and t is equal to integrations from 0 to infinity u is a function of x and t sin sx ds. Okay, so this is a u bar is a transformation of the u. So that's why here we can write the du bar by the dt. Okay, so now this is, we have the expressions after applying the sign transformations. Now u is 0 at x is equal to 0. So here we can put 0, then these expressions become du bar by dt minus or the plus s square u bar is equal to 0. Okay, so this is the first order differential equations, and we know the solutions of this first order differential equations, that is, or also we can write d plus s square into u bar is equal to 0. Now the solutions of this differential equations, u bar is equal to a into e raised to minus s square t. Okay, so this is the solutions of this differential equations, and this u bar is a function of the s and t, or also we can write is equal to a into e raised to minus s square t. Now u bar at t is equal to 0, then it is a into e raised to minus a square into 0. So this is a1. Okay, so u bar at t is equal to 0, it is equal to a. And also we know the u bar is Fourier transformation of the u, so we can write 0 to infinity, okay, u which is function of x and t sine sx ds. Okay, so here u bar, if you find the u bar and at the t is equal to 0, then it is u bar is 0 is equal to integrations over 0 to infinity, and the second condition is given, that is u at the x u is a function of x and t is equal to 1 and 0, okay, when t is equal to 0. Okay, so when t is equal to 0, they given the 1, okay, for this limit, and for the x that is varying from the plus or the 0 to infinity, at that time u is a 0. Okay, so here just I am going to put the u is equal to 1 sine sx ds. Okay, and we know the here 1 into sine n x, and we know the integration of the sine n x with respect to the s, so it is or this limit is also changed from 0 to 1, so it is minus cos s divided by s 0 to infinity, or here 0 to 1, and here 1 minus, or this is minus after substituting limit, minus cos 1, or we can write 1 minus cos s divided by s. Okay, so this is u bar at t is equal to 0, and also we have the u bar at t is equal to 0. So from these expressions and from these expressions, if we compare, then we can write the u bar at t is equal to 0 is equal to a is equal to 1 minus cos s divided by s. Okay, so now we have the a value for the a, and from the u bar, where u is a function of s and t, u bar is equal to, now value for the a we know very well, that is 1 minus cos s divided by s, and the e raised to minus a square into t. This u is a function of s and t, so we can write like this. Okay, so this is, we have the now expression for the u bar, but here we want u. Okay, so by inversion theorems we can write u, which is function of x and t, is equal to under root 2 over pi integrations from 0 to infinity under root 2 over pi 1 minus cos s divided by s e raised to minus a square t into sine sx dx. Okay, so from this we can write u is equal to 2 over pi integrations from 0 to infinity 1 minus cos s divided by s e raised to minus a square into t sine sx dx. Okay, so this is answer for this differential equations, or the solutions of the differential equations by using this boundary value conditions. Okay, now second one, here we applying the sine transformation. Now next example for the cosine transformation. Solve the equations du by dou t is equal to k into dou square u by dou x square, where x is positive and t is also positive. Okay, solve the equations under the conditions, or the subject to the conditions. So they given the conditions, first conditions, that is else we can write u is given at t is equal to 0 is equal to 0 and dou u by dou x is equal to minus a at x is equal to 0. Okay, so these are the two conditions given where u is given but it is at at t is equal to 0, and the du by dx is given, that is minus a at the x is equal to 0. So we know when the du by dx is given at x is equal to 0, then we apply the cosine transformation to these differential equations. Okay, so given du by dt is equal to k square dou square u by dou x square. This is a given, so apply the cosine transformations, that is integrations from 0 to infinity dou u by dou t into cos x dx is equal to integrations from 0 to infinity k into dou square u by dou x square cos x dx. Okay, this is after the applying the cosine transformations. Now we know this we can write du bar by dt, okay, and k into, we know the formula for the dou square u by dou x square cos sx, here the cosine transformation. So for that, minus s square u minus under root 2 over pi du by dx. Okay, so this is a formula for the dou square u by dou x square cos sx dx. Okay, so this u is given at this is u. Okay, this du by dx is given at x is equal to 0, so that is minus 1, so we can replace du bar by dt is equal to k into minus a square u plus a into under root 2 over pi. Okay, so this is we have the now expressions. We replace the du by dx with the minus a, okay, at the x is equal to 0. So du bar by dt is equal to, this is u bar plus k square u bar is equal to a into k under root 2 over pi. Okay, so this is, we have the now differential equations. Now if I compare these differential equations with the dy by dx plus py is equal to q. Okay, if we compare these expressions with this general differential equation, then the p is equal to k square and the q is equal to a into k under root 2 over pi. Okay, so we know the very well solutions of these differential equations, that is y into integrations of e raised to, or y into e raised to integration of p dx is equal to integrations of q into integrations of p dx into dx plus c. Okay, so this is the general solutions of this equations. Okay, so here y is equal to u bar and e raised to integration of p dx. So p is what, k square and the dx, that is nothing but the dt, is equal to integrations of q is a into k under root 2 over pi, okay, e raised to integrations k square dt into dt plus c. Okay, so this is general expressions for these solutions. Okay, so u bar e raised to k square t is equal to a into k under root 2 over pi, and the integrations, sorry, e raised to integration, that is k square t into integrations e raised to k square t into dt plus c. Okay, so again if I integration this thing, so it is a into k under root 2 over pi e raised to k square t divided by k square plus c. Okay, and this k will be the cancel out, and the final solutions, that is u bar is a function of s and t is equal to a into a divided by s square under root 2 over pi plus c into a raised to minus k square. Okay. So this is, we have now solutions of the differential equations, but here u bar is a function of s and t is equal to a by s square under root 2 by pi plus c into e raised to minus k square t. Okay, so here this c, that is the constants that first we have to find out. So apply the first conditions, that is u is given at t is equal to, u is given is equal to 0 at the t is equal to 0. Okay, so if I put u is 0 at t is equal to 0, then u bar is also 0. Okay, at the t is equal to 0. So this, from this we can write u bar, or it is 0 is equal to a by s square under root 2 over pi plus c into e raised to minus k square into 0. Okay, because t is equal to 0, this t is 0. Okay, so from this we can write c is equal to a by s square under root 2 over pi. Okay, so this is, we have the expression for the c. Now from these expressions we can again write u bar, which is function of s and t, is equal to a by s square into under root 2 by pi plus a by s square, here is a minus signs. Okay, so here is also minus, a by s square under root 2 by pi e raised to minus k square into t. Okay, so this is total expressions for the u bar. Okay, and also we can rewrite u bar, just take out this common, that is u bar is a function of s and t, a by s square under root 2 over pi into 1 minus e raised to k s square into t. Okay, so this is u bar, but we want u, that is function of x and t, is equal to under root 2 over pi integrations from 0 to infinity a divided by s square under root 2 over pi 1 minus e raised to k s square t. Okay, into cos sx dx. Okay, this is from the inversion theorems. And 2 over pi into a by s square integrations from 0 to infinity 1 minus k s square t cos sx dx. Okay, so this is u for this differential equations. Okay, so we are going to stop here. We will discuss in the next lecture.